Okay. For this video, I'm going to discuss the idea of equivalent propositional forms. Okay. Equivalent propositional forms. This refers to two statements or two propositional forms for which the truth tables are the same or identical. And we denote the equivalence by, let's say that capital letter P is a propositional form. Then we use this symbol, okay, to say that it is equivalent to other prepositional form Q, okay. Now, to determine whether two propositional forms are equivalent or not, let's consider some examples to illustrate that. For example number 1, let's check on negation of P or negation of Q and negation of P and Q. Okay. How do we determine whether they are equivalent? Again, by constructing the truth table. We can actually choose to construct the truth table of these two statements separately, but what I'm going to do here is to construct only one table for both of them. We'll just separate them by a column. Okay, so let's construct the truth table now. Now, there are two propositional variables, so that means that we have how many possible combinations? We have 4, no? Because we have 2 squared. And these are true for P and Q, true for P and false for Q, false for P, true for Q, and false for P and Q. Then in this column we construct the truth table for the first statement. Now, to construct the truth table for that statement, we have to first determine the truth value of P or not Q before this negation outside can be applied. Okay, well, we have for our Q, P of course is known here to be true, false, false, so you can choose to write that again, or you may choose not to write that again. I will choose not to write that anymore, okay. Let's just write the truth value for negation of Q. Following this, we have false, we have true, false, and this is true. Okay, then what is the truth value for P or not Q, where P is true, false, false? Under or, this is true or false. Maybe to avoid confusion, let's just write the truth value for P. Okay, and then find now the truth value for P or not Q. So this is true, this is false, this is true. Take note of this. Okay, and we're now going to apply the negation outside. We apply it on this particular column because this column here represents the truth value of P or not Q. So under negation we have false, we have false, we have true, and then we have false. And let's mark this. Maybe we can indicate this with an asterisk. So that's for our first statement. For our second statement, we have negation of P and Q. What is negation of P? Negation of P is the negation of this column, which is false, false, true, and true. Let's just copy the column for Q. We have true, false, true, false. Under and, this is false, this is false, this is true, and this is false. Let's mark this and compare it with our truth table for the first statement. Okay, so we can see that they are identical. So we say that negation of P or negation of Q and negation of P and Q are equivalent. Or you can also write this in using that notation. Negation of P or negation of Q is equivalent to negation of P and Q. Okay. Now for our second example, let's choose more challenging problem. We, for example, determine whether the statement P or Q and R and the statement P or Q and P or R are equivalent. How do we determine that? By again using the truth table. But you will see here that you have how many propositional variables? You have P, Q, and R. So that means you have 3 propositional variables. That means that there are 2 cubed or 2 to the 3 possible combinations, no, which is 8. And what are those combinations? First, we have for the 3 variables to be true, then true for P and Q and false for R, true for P, false for Q, and true for R, true for P, and then false for Q and false for R. Then false for P, true for Q, and true for R, false, then true, false, 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 true, and false, false, false. So you see there are 8 rows. Then for our first statement, okay, I think this time we will no longer copy the or rewrite the truth value for P, for Q, and for R. Let's just refer to our first 3 columns here. But before we can apply this connective, we have to determine first the truth value of this one, right? Okay, so you have Q and R. Q and R, true, true. So that's true. This is false, right? This one is false. This is false. This is true. This is false. This is false. And this is false. While for this connective, and we write the final column, okay, for this statement. Combining P and Q and R, where the truth value of Q and R are these. Okay, so we have P or true or true. gives us true. True or false is true. This is true. This is true. This is true. Now this one is false, right? False or false. This is also false, and this is false. Okay. And let's mark this with asterisk as our final column, or the truth table for the first statement. Now for the second statement, we have P or Q and P or R. First, we find the truth value for P or Q and truth value for P or R. Okay, then this will serve as our final column here. What is P or Q? This is true, right? This is true. This is true. This is true. This is true. This one is true. Well, this one is false. This is false. Then P or R. That's or, no? So you have true. You have true. 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 False. True. Then false. And then for our final column, we relate these two columns here under and. So this is true. This is true. This is true. This is true. True. False. 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 Then let's mark this as double asterisk and compare it with asterisk. Okay. Do we have an identical truth table? Yes. So therefore we say that P or Q and R is equivalent to P or Q and P or R. So that's it for equivalent propositional forms. See you again next time, and God bless.